I present here a parametric design of an unpretentious hyperboloid. Here are the parameters. Beta is the tilt angle of its contact line. R is its radius at the narrowest part. Thickness is, well, its thickness. A hyperboloid can be seen as a cylinder that has been twisted at each of its ends. Gamma is this twist angle. The first parameter contact line is the height of the cylinder. It is also the length of the contact line of the hyperboloid. With these few parameters we have everything we need to sketch the profile of the hyperboloid. I trace a line corresponding to the radius at the narrowest point of the hyperboloid. And here is its axis. I trace a radius at one end of the hyperboloid. And now I sample some points of the hyperbola that will be used to generate the hyperboloid. Parametric expressions may seem complicated, but they are only the result of a relatively simple analytical calculation. I'll let you focus on that. The hyperbola having an axis of symmetry, I duplicate these few sampled points using the mirror feature. I connect all the points by a spline. The sketch is done. I create a second sketch. It contains the dip point of the hyperbola obtained by projection from the first sketch. I then trace the contact line on it. It will not be used for the design itself, but as a reference to visualize the contact line on the hyperboloid. The latter is obtained by simply rotating the hyperbola of the first sketch. The hyperboloid is finalized, we can see its line of contact. Without transition I design a second hyperboloid. I add the four parameters that are specific to it. They are beta, r, thickness, and gamma. There is one parameter that I have not duplicated, it is contact line. It is common to both hyperboloids. The idea is to build this second hyperboloid by juxtaposing it to the first one. If I did not make mistakes in the calculations and if I did not make mistakes in the design, the joining will be done exactly on the contact line of each of the two hyperboloids. The contact lines will merge so that only one will be visible. The design of this second hyperboloid is similar to that of the first, a main sketch containing its profile. I thus trace an axis and a hyperbola. The hyperbola is sampled by a few points. The profile of the second hyperboloid is completed. It is the turn of its contact line. And I finish it by using its profile with the revolve feature. I have completed the design. I make the two hyperboloids visible in their relative positions. As expected, their contact lines are overlapped into one. I can now change the parameters values to observe their impact. By changing the contact line parameter I act on the two hyperboloids. It impacts their thickness, their twist angle, and their diameter at their ends. The tilt angle of their contact line is not affected. Neither is the skew angle between their axes. In fact, the skew angle between their axes is the sum of their tilt angles. The other parameters only affect their corresponding hyperboloid. I can thus change independently their diameter via their r parameter, and the tilt angle of their contact line via their beta parameter. If we observe carefully, we can see that in some cases the hyperboloids interfere with each other outside the contact line. Some parameter values are therefore not appropriate if one wishes to avoid these interferences. Nevertheless, we will see in a next presentation how to exploit hyperboloid modeling in a concrete case. Stay tuned.